Let us discuss the electric flux through lateral surface of a cylinder due to a point charge. In this situation here, you can see we are given with a cylindrical surface of length L and radius R, and at the center of this a point charge Q is placed. We know that due to this point charge, electric flux will be emitted in the radially outward direction. And say here we are required to find the electric flux through the lateral cylindrical surface of the cylinder. We know that due to the point charge, electric field at every point will be different. So we need to consider an element on the surface where electric field magnitude will be same. So here at a distance x from the charge, we consider a circular strip or a ring shaped element which is of width dx, and in this situation from the elemental section of width dx we can see the electric flux will be going in radially outward direction due to the electric field, and the direction of this electric field is in radial direction away from the point charge, and the magnitude of this electric field can be given by kq by this distance square, which can be taken as root of x square plus r square. So it is kq by x square plus r square. And if we talk about the surface area of this element, it will be in radially outward direction like this. And at every point, the angle between this area vector and the electric field will be theta, which is the same angle which this line joining the charge is making with the radius of the cylinder. So here we can see the area of this elemental ring can be written as 2 pi r dx because its width is dx and the circumference is 2 pi r. So it will just be like a rectangular strip of length 2 pi r and width dx. Now in this situation, let d phi is the flux through the elemental ring, then this d phi can be written as E ds cos theta, and here if we substitute the values, this d phi will be kq by x square plus r square. Elemental area we can write as 2 pi r dx, and in this situation this cos theta can be written as r by root of x square plus r square. So in this situation, this is the flux passing through the elemental ring, and if we wish to find out the flux through the total lateral surface, then we can write total flux through lateral surface of a cylinder is, this total flux can be written as integration of d phi, and this can be carried out as integration of, this can be written as 2 pi kqr square dx by x square plus r square to power 3 by 2, and this will be integrated from minus L by 2 to plus L by 2. And if we just execute the integration, this is a standard result which can be written as, in this situation we can write k as 1 by 4 pi epsilon naught, where pi and this 2 gets cancelled out. So this will be qr square by 2 epsilon naught, and integration of dx by x square plus r square. On integration, this will give us x by r square root of x square plus r square, and limits we substitute from minus L by 2 to plus L by 2. And if you just substitute the limits here, r square gets cancelled out, and the total flux we can write as q by epsilon naught L by root of L square plus 4r square. This is the final result you will get as the electric flux through the lateral surface of a cylindrical region, and this can be directly calculated later on. You can try by using the solid angle concept, that the total flux emitted by the charge in a 4 pi solid angle. Using that concept also later on you can try and get the result.